All right, welcome to your Unit 8 Notes 3 video. This is Miss Johnson, and I'm going to be talking to you today about rationalizing the denominator. Our lesson objectives today are simplifying a radical expression, which we've been doing for a few days now, and also rationalize the denominator of a radical expression. Let's just go back and review the concept of that we've been talking about the last few days of simplifying and combining like radicals. If I were going to simplify the first one in number 1, I need to break down the 12, which is 2 times 2 times 3. Break down the 48, which is 2 times 2 times 2 times 2 times 3. And break down the 27, which is 3 times 3 times 3. And that just comes from the prime factorization of those three numbers. So if I look at what I can simplify in all those, 4 root 12, I'm going to kind of try and write small here. 4 root 12 would be 4 square root 2 times 2 times 3, minus 7 square root 2, 2, 2, 2, and 3, and plus 3 square root 3, 3, and 3. And I look for my pairs. I can take a pair of 2's out, 2 pairs of 2's, and a pair of 3's. And remember, when we take those out, they go away. They disappear from under the radical. So now outside, I have 4 times 2 root 3, minus 7 times 2 times 2 root 3, plus 3 times 3 root 3. Putting that all together, that's 8 root 3 minus 28 root 3 plus 9 root 3, and they're all like radicals. I can put them all together, so I'm going to go ahead and do that. 8 minus 28 plus 9 ends up giving me negative 11. So this is negative 11 square root 3. For the second one, if I break down the 18, 18 is the same thing as 2 times 3 times 3, prime factorization again. 32 is 2 times 2 times 2 times 2 times 2. And again, that's still just doing the prime factorization, which we've been practicing. So if I rewrite those all out, I'd have the square root of 2 times 3 times 3 all over 2 times 2 times 2 times 2 times 2. Now I noticed some of you, when you were doing these fractions, you were treating them as separate numbers, and then you forgot to put them back underneath the radical as a fraction. So don't forget that they're still a fraction, and I'm going to still keep them that way. So I've got 3 root 2 on the top, and then I have 2 times 2 root 2 on the bottom. That's the same thing as 3 root 2 over 4 root 2. And remember that any number over itself cancels, so that's 3/4. I want you to pause the video at this time and see if you can finish number 3 on your own. Now, simplified form of a radical expression. These are the 3 things that we have to have. We talked about these in notes 1 and also in notes 2. No perfect squares under the radical, no fractions under the radical, which we've been fixing so far. Today we're going to concentrate on no radicals in the denominator. And to do that, we have to rationalize the denominator. We have to make the denominator a rational number. If the denominator is an irrational number, then it's a decimal that goes on and on forever that doesn't repeat. So we'd be dividing forever and we'd never finish dividing. That's not possible. We have to get that denominator to be rational. So that means it has to be some sort of fraction with a terminating or repeating decimal. One example would be 1/3. That's a repeating decimal, 0.3333, and it goes on and on forever. A terminating decimal is 1/5. That's just one example because it's 0.5, and then it terminates. I'm sorry, I meant 1/2. Hello. 1/2, 0.5, and then it terminates. Now, in order to rationalize the denominator, these are our steps. So why don't you go ahead and pause the video at this time and write down these steps for rationalizing the denominator. Let's take a look at some examples. In number 1, I have the square root of 1 over 18. Okay, so the first thing in my steps was to simplify the radical. I can't simplify the square root of 1, one's already alone. So I can break down the 18. 18 is the same thing. If I break that down into like 2 and 9, then I'd have 2 and 3 and 3. So this is the same thing as the square root of 1 over 2 times 3 times 3. Now remember, we're looking for those pairs, so this 3 is going to come outside. That's the square root of 1 over, 3 square root of 2. So now I have to look at what's left in the denominator. I've done all the simplifying that I can do, but I cannot leave the square root of 2 in the denominator. If you found the square root of 2 on your calculator, it would be a decimal that does not repeat and does not end. So we have to fix that. We have to get that out of there because that's an irrational number. So I'm going to, in order to fix that, I'm going to square it. I'm going to multiply it by itself. And by doing that, if we just come over here and take a look at that, the square root of 2 times the square root of 2, I can multiply underneath. That gives me the square root of 4. We all know that the square root of 4 is equal to 2. Okay, so now I've gotten rid of the radical and I have a rational number. By squaring that, the radical is now gone. Okay, so that's what we're going to do. Let's just move that down for now. So, but remember that whatever we divide by in the bottom, I also have to divide by in the top. So I'm going to have the square root of 1 times the square root of 2, which is the square root of 2, because again, I just multiply what's underneath together. And then in the bottom, these two come out of the radical because they make a pair and they come out. So I have 3 times 2 in the bottom. That's the square root of 2 over 6. Now, some of you may look at that and think, oh, 2 6, I can reduce that. Be very careful. One of these numbers is under the radical, and one of them is not. So you actually cannot reduce them, okay, because they have to be in the same position, and in this case, they're not. So this is as simplified as we can get, and that's our simplified radical with a rational denominator. All right, so let's take a look at the next one. In the next one, I have the square root of 1 over 3. Now, the square root of 1, I can't break down at all. The square root of 3, I can't break down at all. So that's as simplified as I can get it right now. If I think of those as two separate radicals, okay, because I can split them apart like that, I need to rationalize that denominator. And in order to do that, I'm going to multiply by the radical that's there. So I'm going to, in other words, square it. I'm going to multiply by the square root of 3. But remember, whatever we do to the bottom of a fraction, we have to do to the top. So when I multiply the square root of 3, let's just review that again. Square root of 3 times the square root of 3, that's the same thing as the square root of 3 times 3. And there's even two different ways to look at that. I can think of that as 3 times 3, there's a pair, it can come outside the radical. Or I can think of that as the square root of 9, which we all know is 3. No matter what way you look at it, we're going to end up with 3 outside the radical, which is what we want. So in the bottom, these two make a pair, come outside. I have 3 without a radical. And in the top, I multiply square root of 1 times the square root of 3 is the square root of 3. Again, I can't reduce this because the top is under the radical, but the bottom is not. So that's my most simplified answer. Okay, let's do one more together. Square root of 27 over 15. Now, I'm willing to bet that I can take some perfect squares out of 27 and 15, or I'm at least going to try, because I know I can break both those numbers down. So let's start with the 27. When I break down 27, I'm going to make that 3 and 9. That's 3 and 3. There's my prime factorization. When I break down the 15, 15 is just 3 and 5. No pairs in 3 and 5, so I can't do anything with the 15. But I have a pair in 27, so I'm going to break that down. This is the square root of 3 times 3 times 3. And again, the square root of 15, can't do anything with it, so I'm just going to leave it for now. All right, so I can take my pair out. That's going to come out front, and those go away. I have 3 root 3 over the square root of 15, and now I need to rationalize. Okay, so I'm going to multiply by the square root of 15 because that's what's in the bottom. Okay, when I multiply the bottom by itself, or in other words, square it, that cancels out the radical, and I'm left with just 15 on the bottom. Okay. On the top, I have 3 times 15 underneath the radical. So this 3 is still out front. Then 3 times 15 is underneath, which is the square root of 45. Okay. Now I have to go back and simplify again. Take a look at that 45. See if there's anything you can take out of that. 45 is the same thing as 3 times 15, which is what we just multiplied to get there. I can break down the 15 into 3 and 5, and look at that. Here's a pair. So now I know I have some more simplifying to do. That's why in your steps it said simplify, then rationalize, then simplify again. Okay, so let's break that down. I have 3 times the square root of 3 times 5. The bottom is just 15, and we'll come back to that in a second. Now I'm going to take my pair out. So this comes out front. I have 3 times 3 times the square root of 5 over 15. 3 times 3 we all know is 9. So I have 9 square root 5 over 15. Now, it looks like we're done, and we're very, very close, but there's one other tiny thing that we need to think about, and it's the fact that 9 and 15 have a common factor of 3. So if I divide by that common factor, 9 divided by 3 is 3, 15 divided by 3 is 5. I now have 3 square root 5 over 5. Now my denominator is rational. I have no perfect squares under the radical. I have no radical in the denominator, and everything is as simplified as it can get. That's my final answer. So basically you just need to keep simplifying as much as you can until we get down to the end. I want you to pause the video at this time and see if you can work on number 4. And we're going to call that the end of our video for today. Thanks for watching. Don't forget to go back and take your Schoology quiz, and we'll finish up our notes in class tomorrow. Have a great night.